youth counseling. We are incredibly fortunate to have Dr. Doreen with us today to share her profound knowledge and experience. I welcome Dr. Doreen to lead us through this enlightening session. Welcome, ma'am.
Thank you, Sandhya ma'am, for the good introduction. Good evening, all. All right. I'd like to thank the entire management of SRM Valliammai, especially Shanbagavadi ma'am, Narayanan sir. I've been closely associated with SRM for the past 6 years, I suppose, right? So thank you for this opportunity. I think this is the third ATAL FDP of this session. I'm handling it, right? So thank you all. How are you all doing today? How are you all doing today? Can I have the answers on chat? I think you can, people, can they use chat? All the faculties, can they use chat? Or on question answers? I could not see chat. You're able to access chat? How are you all doing today? Or I think you can have reactions, right? Can you click on any reactions? Yes, no? I can see Banu, Prakash, Professor giving a thumbs up. Yes, Sandhya ma'am giving a thumbs up. Others? Only two. We have 93 people here. All right. Yeah, thank you, Jay Chandran, Professor Munir Ali. All right. Like there's always possibilities, right? So happy to hear that you're all great. And add that to the session. That's an evening session. Am I audible? A thumbs up, please, if I'm audible. Yes.
Yes, ma'am.
Yeah, thank you so much. So you had been dealing with the different topics, and for me, this is the third session for the day, right? And we have been training for 30 hours for almost 300 students of cybersecurity. Each is 2 hours per day. So today is my day 10. Because of climate, we are online, and just completed. Like it was, it is little difficult, but still, I love sharing and teaching. Right, that's one of my passion of it. So today, let's see into what are the machine learning fundamentals. All right. Mm-hmm. I hope my screen is seen to you. Yes. Can you give me a thumbs up? Yeah, I can see a few thumbs ups. All right. And today we are going to see for the next 1.5 hours about introduction to machine learning foundations and applications. All right. And what is machine learning from your perspective? Anybody, can they unmute and speak, or they use chat? Which is possible, ma'am?
Yes, ma'am. They can unmute and then they can freely speak with you also. Yes, ma'am. And chat box is also enabled to them. They can use both also.
Okay. Maybe chat box I'm not able to see. I'm able to see question and answers, but chat box is little difficult. I don't know. It throws an error.
When participants, you can interact with the resource person.
Yeah. All right. So what is from your perspective? All right. Machine learning. You can put on the chat, you can unmute and speak. You could be right, you could be wrong. All right. This is a beautiful topic on FTP, right? On advanced data science. I think the first FTP that I handled for this session in winter is for RV institutions at Bangalore. They have taken data science with sustainable development goals, right? And again, it is the second FTP was with AR/VR, and now this is with machine learning, right? A deeper part of it. All right. So let's play a game. I'll show you an image. I want you to interact, all right? And I want you to find what is the error on that image. And this is not a error. You know about me already. They have shared about me. I'm basically a data scientist, keynote speaker, machine learning, and deep learning trainer. This is my mail ID. If you wish, you can get connected, maybe for future. What is the mistake in this? Can you unmute and speak, please? What's the mistake? Can you spot the mistake? So I want to give 15 seconds.
Yellow balloon is the problem, ma'am.
Yellow balloon is the problem. What is the problem with yellow balloon?
Its size may be small.
Its size is small. Okay. Good try.
It is not. It is not in his hand.
Okay, it's not in the hand of anyone. Thank you, sir. Good try, but not the right answer. All right, anyone? Yes, 15 seconds is over. Anyone would like to? Those who can keep.
Ma'am, rainbow is there, but the sky is not blue.
The rainbow is there, sky is not blue. All
It's
right.
on the white background.
All right. All right. I'm sorry, there was some mistakes, and that is what I'm not able to. Yeah, there was ma'am who was. Yeah, yes, ma'am. Can you hear me now? Can you all hear me? Yeah. I always say expect the unexpected, right? And that's what this too. Yes, can you tell one ma'am was answering. Is it Usha ma'am, Dr. Usha ma'am? Yeah. You said? Hmm. Okay, okay. Tell me, ma'am. Uma ma'am. Pink color. Okay, okay. It's not. Ah, yes, ma'am. Yes, that's so the right answer. Yeah, the right answer goes to Nitya ma'am. Right, the right answer goes to Nitya ma'am. See, in this picture, every one of us we are trying to figure out different mistakes. I do accept it's a mistake, but the fact, right? More importantly, the fact is that the color of the rainbow starts from violet, indigo, blue, green, yellow, orange, and red. All right. And you see the first color is what is the first color here? What's the first color? It's indigo and then violet. So, how the rainbow should come? That's the mistake. Able to get it? Do you agree with me, professors? Yes? Many a times. Do you agree with me? Yes, no? All right. It's okay, everybody. We have got some time to try it. The reason behind what I'm trying to say is that in data science, right, we need to find, if you know the facts, we'll be able to know the patterns, and we'll be able to go in to figure out what is the insights that we really want to get into. All right. I hope my voice is audible, right? Do you agree with my question? If you agree with my answer, can you give me a thumbs up, please? Yes, if you agree with my answer. The answer is wrong, right? Yes or no? All right. So this is what is very important in data science, knowing the facts. Let's try one more. What's wrong with this picture? I hope you're able to see my screen. What's wrong with this picture? You can unmute and speak. I give you 15 seconds. Please feel free to unmute and speak. Please keep your cameras on to the possible extent. Yes, please. Yeah, 15 seconds is done. Can any of us say what is the mistakes in this? Yes or no? Am I audible or not? Am I audible? Hello? Because I'm not getting any response. What is the mistake in this picture? Anybody? Any tries? Fast, fast. Try to think of the facts and then apply. What do you see on the picture? What do you see on the picture? Kindly. You could be right. Ah, one fruit is odd. Okay. Thank you. Thank you. Thank you. Then, what it is collecting? It is collecting strawberries. Do you like it? Is strawberry. Any other one more? I'll give chances for two more people to give response. One professor already gave two more. Kindly give any response. You're 114. That's really a good number. Yeah. Yes, tell me. What do you see? The fruit is strawberry, right? Anyone? Please do answer, please. No more? Okay. You see, it is strawberry. Remember everybody would have studied in a middle school. Strawberry do not grow on bushes. All right. Strawberry grows like this. Strawberry does not grow on bushes. So that's the wrong in this picture. Why I have shared these two pictures, you may wonder we are going to see about machine learning, its fundamentals and applications. All right. But this is one such trigger factor we need to know on data science, all right, without knowing facts, because systems can work with lakhs and lakhs of data, right? Some of you would be data work with lot of machine learning algorithms, right? You can develop on your own. You can use Skykit. You can get codings or content from GitHub, Kaggle. You have your students working on with that, so much and so more. But importantly, what machine learning can do, it can process, you and me cannot process 10 lakhs of data in microseconds. Do you agree with me? But a machine learning algorithm can access 10 lakhs of data in microseconds. At our research organization, one project we worked with the drought analysis. The data was almost 1.2 crores of data, but it worked within microseconds and we got the results out of it. All right. So this is what the capable of machine is. One thing the machine is not capable of is called it does not have common sense. That is why you and me we have. So without knowing facts, data science or machine learning or deep learning, it's all the umbrella word that I may speak about with clear little distinctions about it. But everything learns with the patterns of the data, learning the patterns of data. When you take data science is an interdisciplinary field that uses scientific methods, it processes different algorithms. All right, it uses systems to extract knowledge. That is what it is. From the system, we need to extract knowledge, find patterns, and then we have to recommend things, right? It insights from structured and unstructured data and applying knowledge into actionable insights from data. All right. How many of you watch YouTube? Right? Do you watch vlog? Do you watch YouTube videos? If so, click recent or like. Okay. Yeah, we also. When you see a YouTube video onto the right, do you see relative videos onto the same time? Yes, no? So, why do you think, say, for example, you are going to teach about DevOps, like development and operation? Like, I know all the faculties, we would have not learned those subjects when we were in our college. Right? What we are teaching is something different from what we have in our college, right? But we learn, right? Sometimes one of our resources is can be YouTube. When you see a video for DevOps on YouTube, maybe Ensemble or Jenkins or whatever it is, you'll be seeing relative videos onto the right. The machine that runs behind, the machine learning algorithm that runs behind it is called as the recommendation system. How this recommendation system works, right? Every user, when you click on to the videos, you find it is interesting, then you watch over the video, then you go to the next chain of video. It finds the data patterns and builds the blocking, or it builds the chaining of videos. That is what you get it onto the right. Maybe you see a video on DevOps. For example, I'm telling about DevOps this month. You see after 6 months, the recommendation will not be the same because YouTube has its inbuilt machine learning algorithm. All right. How many of you, which is one of the, we buy a lot of products in online, right? Which applications you use the most? Either you can unmute and speak, or you can put the answers on the chat. I don't know. For me, chat is not working. You can put it on QA also. I'll be able to find answers from that. What is the most the app that you use frequently to buy some things through online? Maybe for home or something like that. Amazon. Thank you, Professor J. Chandran. It's Amazon. Others? We have Flipkart. Okay, Flipkart, Amazon. Yes, thank you. All right. When you buy, say for example, I'm going to take Amazon. Like maybe the recent product, I know, if you want to buy a mobile phone, for example, when you search for a mobile phone, or whether you're able to see beneath, customer who viewed this product has also viewed these products. Have you seen it? Yes, no? Let's be little. Yes. How how does that happen? How does that happen? The reason behind, there is a machine learning algorithm that runs on Amazon that takes the patterns, how people search for what is the specification, what is the RAM, what is the brand, what is the pricing, and every search get built. That is called as a recommendation system, right? So what recommendation system, it from the previous user's experience, it tries to recommend to the new user, this could be also a better product for you to see. When you go to shop, they say, if you're going to buy a shop, for example, if you want to buy a sari for 2000 rupees, right, you ask for a model, then the shopkeeper will come, ma'am, see, these are the models available, because there's a human present on a physical shop, but you're not having any human present, but the number of interactions. Can any one of you Google and tell me how many products does Amazon sells per day? Yes, quick, please. I want answers on QA, or you can unmute and speak. How many products Amazon sells per day? Approximately, yeah. Uh, the reason, yeah, products around 600 million products. Amazon sells over 12 million items per day. All right. This is based on 2023. Still, we have not seen about 2024. All right. See the amount, the number of items is huge. Yes. Do you agree with me? You cannot employ people. See, this is the effectiveness of machine learning. All right, this is the effectiveness of every interaction, every click that you do. There's an algorithm that captures your data behind, right? So now there are many Python libraries available to develop your data science, right? First, we need to do on the visualization. The packages are called NumPy, which stands for numerical Python, Pandas for data analysis and visualization, Matplotlib is for visualization, right? So for analysis, it is Pandas. For numerical Python, right? How many of you have? We are all mostly you may be computer science professionals, sorry, engineering professionals, right? And how many of you are engineers? You're working in engineering college? Yes, most of you. Yeah, I can see. Yes, I can see Sam King. All right. Yes, Sendil Kumaran sir, Venkateshan sir. Others? Yeah. So, we should have learned a lot of difficult mathematical applications, right? All those things you can use it using NumPy, right? We import NumPy as NP, which stands for numerical Python. See, what are the applications that you can use? You can work with quantum computing. You can use with statistical computing. If you are an EC professional, you can work with sometimes. See, at CIRF, we work with four pillars. One is research, development, education, and training. In training, students come for internships. Mechanical students come, ECE students come, MSc physics students come, chemistry students come. I teach them all basically data science because it is going to be one of the mandatory skill from 2020 into any job. See, signal processing, they can work, image processing, graph networks, astronomy, cognitive, right? Architecture and engineering, geography process, geoscience, chemistry, mathematical analysis. Can you see bioinformatics? And when you see SkyPy, right, you can see what are the difficult components, right? Everything it has got its own in building. You can see like eigenvectors, sorry, you can see eigenvectors, right? Integration, differentiation, all its statistics, everything could be applied using this. How many of you have worked with NumPy, or is it new? I don't know. How many of you work with NumPy? Yes, I can see Sendil Kumar sir, Dr. Venkateshan sir. All right. All right, Uma Geshwari ma'am, right? Maybe some you would have already worked. For some, it will be new, right? So, what is machine learning and deep learning? Right? Both machine learning, a part of machine learning is a part of AI. A subset of AI is machine learning. Subset of machine learning is deep learning. All right. So both machine learning and deep learning, they discover patterns in data, but they involve dramatically different techniques. So that's what I always say. Data science is such that you are figuring out patterns of data. How many of you have got some close friends in your college, now in your workplace? Do you have close friends? Or you don't have friends at all? If you have got good friends, right? Click raise hands, right? Yeah. Okay, like Usha ma'am, most of you, Nitya ma'am, Jay Chandran sir, right, Gopinath sir, right. I hope I'm spelling it right. Yeah, Ashwin Kumar sir, Shiva, everybody. You remember yourself. Maybe they are college students, your friends, or workplace, their friends. I don't know. Remember our first interaction, right? Even when we go to college, when we have gone to college, right? First day, we smile at everyone, all the friends in our college, right? When going back to memories of being a student, right? But when you come to second year, then we have little gangs that we have, right? When we go to third year, it becomes even more stronger. When it becomes final year, we know who are our close friends. Even by the end of first year, we'll know who are our close friends. We try to find whose behavior matches with our behavior or only our friends. It takes time for us to experiment, to find out, to discover, and whose wavelength will work out with us, and then we become friends. It takes time. Yes or no? Do you agree with me? Yes. So we spend time with them, and then who helps us? who helps us in time of need, then here we are trying to discovering the behavioral patterns, and then we become friends, right? Same thing works out in data science, but it is working in huge volumes of data, discovering the data patterns. All right, it discovers the data patterns. All right, so when you see both looks the same, machine learning and deep learning, both discovers patterns of data, but the way they find patterns of data is different. All these things, both machine learning and deep learning, are both forms of artificial intelligence, right? So when you see deep learning, it's a specific, and that's what I say, the entire shell is artificial intelligence. A subset of AI is machine learning. Subset of machine learning is deep learning. All right. So today we're going to see about machine learning by and large, but let's know what's the difference between machine learning and deep learning. See, for example, when you see machine learning, they both start with training data and testing data. That's the first step. Then they go to a model, and then they go to the optimization. We are all professors, right? We are all professors in engineering or any college, right? So what it generally does, right? What it generally does, if you see to it, um, when students are coming to a college, first we give them different internals. How many internal exam do you conduct in your college? One or two? Ah, three internals. By the end of third internal, you will know who will pass in the end semester, who will fail in the end semester. Yes or no? We'll tell the students. We know because we know them. We are the one who trained them right from first internal, second internal, third internal, and we know we keep special classes. We ask the students to stay back or something or the other. We know who are the students who maybe fails, right? Because of our experience, that is a training set. But in the examination, what they do, it right? In training, you know the results, but in the testing you'll not know the resultant data. So testing is the testing phase, or the data is where they appear for their final examination, and more than our expectation, many students they pass on the final exam too, right? So and then they go through. See, every year do you teach the same method, or you keep changing the methodology of teaching? Yes, thank you, Jayachandran sir. You're some active professor, right? We keep changing. We know which student, like some batches, but I don't know. I always tell my students, right, in all my 10 years of teaching, I never say you are the best batch. Every batch, I'll say you are the best than the previous batch. You are best than the previous batch, right? And students will tell me sometimes, many a times, professor says, you are the worst batch. Why, ma'am, you always say to that? Because I think every batch is best because I am changing myself the way that I teach. Like for example, I'm handling now. We are teaching for all PG students cybersecurity 30 hours course as prescribed by UGC, for MA English, for psychology, for FSND, like MCOM, different. If you see on my LinkedIn page, you'll be able to figure it out. This is the third time I'm handling the session. Like already we have handled, like had trained 600 students, like 2022, 23, yeah, 24, we are doing it, right? But my content is not the same because the number of cyber crimes and the methodology of cyber crimes and the cases are different, and every time I handle is different. Maybe the core is the same, but the way I handle is different. So we know how the students are, and we are trying to optimize ourselves and present the best to the students, right? As faculties, teaching is such a noble job that we try to build the next generation. All right, it cannot be taken as granted because you all want to learn something new. That is what, even after a day's work, you're all joined to this FTP, like 135 people into the session. Even for me, it's like taking 4 periods, right? Continuous 4 hours, right? 2 hours and then a break, and then 2 hours for addressing 300 students, and back. This is third session because I always desire to teach somebody, right? Or to learn what I know others should know. All right, if they are interested. So when I take artificial intelligence, machine is able to carry out work in a smarter way. Can you tell any machines that is able to work in a smarter way that we have it at home or wherever we travel? Any simple examples anybody can say? Those who have not answered can answer. We have so many people here today. Yes. Can anyone say? Yes, ma'am. Robots. A simple example. How many of you have washing machine at home? We have washing machine at what it does, it's machine enabled, right? You tell this is cotton, this is what I need, and then it does the job what we do. Yes or no? Very, very, very simple example of artificial intelligence. You take a dishwasher, microwave, right? Very simplest example of artificial, where the machine is able to carry your task on its own in a smarter way. All right. Then the subset of machine AI, artificial intelligence, is machine learning. What is machine learning? It make allows the machine to give access to data, and they learn themselves and explore for themselves, right? So the machine should be given access. You know about Alexa, Siri, Google Assistant. All right. How Google Assistant, Siri, and all works? You have used it, Alexa. Yes. Yes, ma'am. We try to give an instruction, right, we try to give an instruction. Alexa, do this. Alexa, do that. Alexa, do this. All right, these are example of weaker AI, but still it is it's a subset that we give data and they learn themselves and they do it, right? And the major clusters of machine learning is called classification, clustering, and regression, right? What is classification, right? What is classification in the sense, you, for example, when I'm going to take a data set, right, and the best data set that you can take it is from the UCI machine learning repository. How many of you have used UCI machine learning repository? Can you click raise hands, or any kind of reactions can you give if you have used UCI machine learning repository? Yes, no? Either give me yes or no. All right. Yeah. Who said yes? Right. Okay, Adlin ma. All right. So UCI machine learning repository, here when you come into it, see here they give you enormous data set for you. Maybe some of your beginners in machine learning, some of your middle level, some of you could be even experts in machine learning. So this is one of the best data set that you can get for to do work with machine learning repository. Can you see here classification? Right? How many data sets? 672 data sets. Right? Say, for example, I'm going to get Twitter geospatial data, and here they will give what are the tasks you can do with the data set. Here they've been giving all the three tasks can be done. That is what they say: classification, clustering, and regression. Right? So, what is classification means? When you have something like a target, right? When you see the data set, you can see how many instances are there. When you have a target, then you find it, right? It is, you can work with classification. Say, for example, disease data sets. If I'm going to take, I'm just searching like disease. All right. Mhm. See, I'm taking heart disease, right? So heart disease is there. This is 303 instances. And when I see to it, let me make it 15. Can you see there's something called target? Yes. Whenever I have a target, which means the diagnostics, maybe they are heart patient or not, taking these values. Very simple example I'm taking, right? So any data set that has a target, if you take students' data, right, with the marks, whether they are pass or fail, like if I take disease data set, then it shows like whether they have a particular disease or not. Can any one of you give me example data set that may have a target? Yes, please. Yes. Ah, diabetics data set. Exactly correct. Yes, sir. Then your diabetes, if you an AC or you're be fasting and post, how it is, and then we'll see to it whether you're diabetes or not. Then COVID, exactly whether you're COVID patient or not. And also an example for every year you get so many applications for your college. How many students admitted, yes or no? That is also a target, yes, other than disease, right? All right. You wait for a ticketing system on a railway station or a flight, whether you get the ticket or not. Maybe you get a ticket or you get an RAC or get a waiting list. Yes. Any application that has a defined target, it comes under classification. All right. Any data set that has a target, then it comes under class. All right. And next is clustering. Right. So what is clustering? Clustering is where you don't have a defined data set. All right. Clustering is something on machine learning. It does not have a defined data set. How many people go to malls? Mall. Do you go to mall? Yeah. For what purpose we all go to malls? What is the purpose? Uh, First, maybe the first target, maybe to see a movie, then others. Tell me. Only for movie you go to mall, and for what other purpose do you go? For shopping, window shopping, then fast. You go some audio, I'm not able to hear it clearly. Do you go for food? Yes? Yes or no? And then we go for movies. Then we go uh, just for free gaming. Then during summer we go for OCAC. Yes? Yes or no? Just to have some free time. All right. Yeah. Without even without any purpose we go to mall and come, all right. So some goes for shopping, some goes for window shopping, some goes for free time or just to spend some time, all right. And you don't have a predefined target. If I'm going to take this data set, when you don't have a predefined target, these kinds of application comes under clustering, all right, on machine learning. Able to understand? So classification, when you want to develop a classification model in machine learning, you need to have a defined data set. Sorry, it's defined target. All right. If not, for clustering, we don't have a defined target, but it could be different clusters. So say for example, when students come into college, right, some students do very well in the first semester. As they journey through, they come down. Generally, if you split a class, we can say above average, average, and below average. This is how we can split our students. So the members in the system will be shifting between above average, average, and below average, but we cannot say this is the predefined target, right? So but where you take exam results, it's a predefined target, right? When you don't have a predefined target and the clusters may increase or decrease, or you don't have any target, it comes under clustering mechanism. For those kinds of data set, you need to use clustering mechanisms, right? On machine learning. The third methodology is called regression. What is regression? It which means it also has a target, but the values of the targets are continuously changing. All right. The values of the you know what is stock price? Is the stock price same or different? Day by day, if it is different. When the target is changing, right? When the values are keep on changing, then you go on for applying regression, right? You have a target, but the target is of changing values. If you buy a piece of land in 2020, and if you're going to buy the same piece of land in 2024, is the land value same or different? Yeah, which is continuous, the gold price. Like the drugs that we take, the drugs, this thing, the medicines. When the child is born, we give paracetamol. That's the target. But the values of the paracetamol is very less, right? 5 ml or even less than that. As the children grew up, all right, but the values keep changing. Yes or no? So for these kinds of application where there's a target and the target is continuous changed variables, then you need to use regression. All right. Is it clear till now? Yes or no? Uh, I generally don't use much of slides, but then I ask people, like, this is about machine learning. The subset of machine learning is deep learning. I'll just give an introduction. We will not delve more into it, right? And it is similar to it, but it is more accurate in comparison with machine learning. But I had worked with maybe thousands and thousands of projects, all right. But what I see, people say the deep learning is more accurate than machine learning. Being be some research scholars, I do guide some research scholars. I train them and they develop on their own. In some cases, I find machine learning is giving good accuracy than deep learning, in rarely in some cases. But what I tell, being a researcher on data science, I tell it depends on the applications, right? For some applications, deep learning does not give good accuracy, whereas machine learning gives good accuracy. For some applications, deep learning gives good accuracy. It depends on application centric that we should keep strong in our minds. All right. And so that's what I say. The entire thing is artificial intelligence. The subset of artificial intelligence is machine learning, and subset of machine learning is deep learning. That's from 1950s to 1980s, then from 1980s to 2010, and now it is on deep learning. All right. So both machine learning and deep learning can handle both numeric and non-numeric. Numeric is regression. I said right, the values keep on changing, right? Non-numeric is yes or no, right? Which is classification problems, right? Which is of classification problems. Objects such as applications such as object detection and language translation. Deep learning gives more better fits than machine learning, right? So deep learning is machine learning. That's what I say. Deep learning is machine learning. All right. And what machine learning does, it parses the data, it learns from the data and applies what they have learned to make informed decisions, right? So, first, whatever data you give, right? Whatever data you give, it tries to parse the data first, right? Once it parses the data, then only it tries to learn the patterns of the data and then learns from the data and makes informed decisions. I told you about the recommendation system. Do you remember? Right? I told you about the recommendation system. So on YouTube, on Amazon, and so much and so more, right? So here, when you see the very simple example of that is a YouTube next video that I told you, all right? Machine learning do progressively when they, but it needs some guidance, right? There's an example called flashlight, right? How machine learning and deep learning. Say, for example, I have audio trained, right? I have audio trained my application, right? As what I say, if I say dark, when I go to the room and if I say dark, immediately what will happen? My lights will be switched on. All right. So that is in machine learning. Able to get it? So when I say lights, then it will be switched on. All right. If sorry, when I go to the room and I say if it is dark, then the lights would be switched on. All right. But if I'm not saying dark, right? But if I'm not saying, I'm not able to see Why the room is like this? If I'm going to see like say these words, machine learning will not work. It can recognize only the word dark. But whereas in deep learning, if I go into the room and I say, I can't see, or if I see the light switch doesn't work, it's not the same word as dark, but it tries to synthesize and then the lights will be switched on. Able to find the difference? Machine learning and deep learning? Yes? Yes or no? This is the difference between machine learning and deep learning. In deep learning, it has a layered structure of algorithms, all right, and then it will try to find it out, right? It will try to find it out and then it will work progressively. But in machine learning, whatever you have trained only should be working on with that, all right? And it is trying to mimic the human brain. How many of you know this Alpha Go program? Oh, sorry, Go game. Go game. How many of you know? It is. How many of you know Go game? Yeah, Usha ma'am, you know Go game. I can see only one raise hands. All right. So Go game is something like a chess game, right? You know, now recently only Gukesh, right? He won the world's champion, right? When you see Go game, this looks like this. I'll show you, right? Can you see? It's very very famous in China, right? How the what rules they have. This they also you have the white and the blacks, and you know this Google's Go Mind, right? Deep Mind, sorry, not Go Mind. Google's Deep Mind. They worked with this, right? They mastered the ancient Go game. Can you see here? And they inspired and they tried to make another AlphaGo, right? So they tried to work with the machines, the AI machine, and the world's topper Go game person also played, you know, AlphaGo won the game in comparison with the human, world's best player, right? Learned the mastering of Chinese Go game and it defeated the world champion, which defeated AlphaGo defeated it. Right? Rapid was developed using deep learning. So the amount of data is more, the performance is more. Amount of data is less, older learning algorithm. So when you see both differences, users parsing data, learn from the data, make informed decisions. All right. That, yes, please. Any doubts? If you are not speaking, you can put your mics on mute. All right. Mic mute. Huh? I think the organizers can mute the mic. All right. That's good. Deep learning creates a new, as we have neurons in a brain, it tries to make the neurons, right? Subset of it. So I told you about there are next concept that we are going to see. These are basic fundamentals, right? That's what we are seeing into it. Here, what is supervised learning? Like you know the target values, right? This is an apple, right? I sent it to the supervisors. It has a training data. It knows what is the output, which means it has got a target. Then it has got its own algorithm. Then it develops it. I'm training using a red apple. I'm testing using a green apple, taking its structures and everything. It says this is also an apple. All right, able to get it? Yes. So this is an example where you know the target, then you go on for supervised learning, right? When you know the target, then you go on for supervised learning. All right. When you don't know the target, can you see the difference here? You have the desired output. When you don't have the target, then it is unsupervised. So I'm trying to give different data sets like apples, orange, and mangoes. It tries to figure out its shapes, right? And then it tries to give it to an algorithm. And with the shapes, it is clustering into apple, banana, and mangoes. All right? Yes? Able to get it? The difference between supervised learning and unsupervised learning? All right. And what happens in deep learning? In deep learning, in machine learning, we extract the features and then we build the classification model. But what happens in deep learning? It both goes hand in hand, right? Both goes hand in hand. All right. Both machine learning and both feature extraction and classification, they go hand in hand. That's what people say. They are more they are more little better than the others, right? But basically it also depends on how it works. But this is the heart of the concepts. This is the heart of the concepts. Any doubts till now? Any doubts till now? No. Only few are answering. I don't know what others. Right. Thank you. Now, how many of you worked with pandas? How many of you worked with pandas? Yes or no? Yes? All right. Yeah, thank you, Munir sir. So, what pandas? How many of you are new or you don't know about pandas? If you are new or you have not worked with pandas, you can click raise hands. Okay, Venkat, Surya, Muttamal, Nitya ma'am, Sandhya ma'am, many of you. All right, no problem. We'll see. All right. So, what is pandas, right? It is stands for pandas for data analysis, right? Let's move on to pandas. So here it has its own structure, right? Where it looks like table kind of data, and you can use it for merging, sorting, and whatever applications that you want to do. Slicing, I'll show you a demo of it, and I can also show you this website. You can also make a note of it. Pandas.pydata.org. Can you make a note of it? Yes. All right. So here you see it gives you how to install pandas. All right. And when you come to documentation here, it gives you the entire user guide, how to use pandas. Can you see if you want to take data from a CSV file, how do you want to index it? All right. I'll show you. Yeah, I think this is about a heart disease data set, right? So I showed you the data set, right? You remember on UCI machine learning repository, even directly from that you can take a data, right? Directly from the data set you can use those data, right? And I have just taken it using pip install UCI ML repo because everything comes in Python as package. You can also visit this website, which is called pypi.org. Can you make a note of it? All right. So here, whatever you want to develop in Python, I'm going to want to do it from UCI machine learning. Then I'm just searching. Then here itself they give you here. See this, I showed you about this heart disease. Do you have an option called import in Python? Can you see it? Yes, when you click on that, you get this entire code. Then this is how you will be installing, right? Pip install UCI machine learning repository. From there, directly I'm going to import the data set, right? These are my features and target. Whenever it is target, it is called as clustering, right? The same thing I'm doing it here. I'm directly importing it. All right. So I'm just installing the package to import, and then I'm directly, this code is given by UCI itself. We can directly use it. So no problem in that. All right. There's no problem in that. So we'll be able to use it directly. I think it's running. Just give me a minute. Now I have taken the entire data set. All right. So I'm going to connect both the data set. So this is, I've taken all the features, right? All the features onto this variable called X, right? Variable called X, target onto Y, right? Target onto Y. So if I am running here, it will X dot hit. So in pandas, everything it comes into pandas here. So if you give X dot, if I want to import, we can import pandas as PD. All right. I don't know why it is quite slow. So I delete it. Okay. So I've imported pandas as PD. I'm trying to have the maximum columns because number of columns are more, right? I can, it's used by saying X dot shape, right? If in pandas, if I import it, I can have it. So you can see how many rows are there. 253,000 rows are there. All right. So because of that, I'm trying to use, or 21 columns I would like to see. That's what in pandas I'm setting it as maximum columns. So what are the features for heart disease, high BP, high cholesterol, cholesterol check, BMI, right? Whether he's a smoker, he has got stroke or disease attack, heart disease or attack, or whether he is physically active, how many fruits he takes, vegetables, whether it's heavy alcohol consumption or any other healthcare, no Dr. BC cost or general health, right? And no voice, or you're not okay. Thank you. Sorry. All right, and then here you can have. I'm using this tool called Colab. I forgot to tell you that. How many of you used Colab? Are you aware of Colab? Yes or no? Kindly give me an answer, please. Anything is fine for me. I want an answer, yes or no. See if you are using. All right. I don't. All right. So, okay. So, when Colab, it comes as a free tool. All right. Colab, it comes as a free tool with your Google. You can just type, if you're also using mobiles or systems, you can type colab.research.google.com. All right. That's the website. I can give you uh, a bigger part of it. You can make a note of it. It will be very, very useful. I always, faculties, yeah, faculty should know more than students, right? Even though I'm busy, whenever it is FDP, I do accept it always, because I strongly believe when the faculties are trained through them, thousands and thousands of students could be trained. All right. This is a website. Kindly, you can make a note. Just log into your Gmail and then give this link. And all your data sets, that's the next level, but directly you can start working with it. It's a free package. Yes. collab.research.google.com. Only as time increases, no, number of people are also increasing. Right, nice. So this is the target. Which mics on mute, please. Mics on mute. The organizers can make anybody's knowingly they should keep their mic on. You can mute it. Mm. All right. Now coming into this, um, using that only I'm trying to do this, right? So a target is whether they are a diabetic patients or not. Sorry, it's not heart patient. I've taken as diabetes patient data sets, CDC diabetic patient data set. And what I showed you is for heart disease, same thing, right? I mean, only the ID will change, right? So it's 303, that is for diabetes, it's for almost 253,000 or something or the other. All right. So this is my target, right? Whether they have got how many rows I have, same rows I have it in my target also. Can you see here? But here there is 21 rows. Here there is only one row, only one column. And the type of the data set, right? Whenever, whatever, if I import it into my pandas, the data type is of data frame. The data type is of data frame. All right. And then I'm concatenating both data sets because I want to merge both my features and my target, the features and my target. So now I made it as a DF, right? So I can find whether first patient is a diabetes patient or non-diabetes patient, right? 0 means they are non-diabetes, 1 is they are diabetes. And in pandas, you have got two things. One is the pandas attribute, the other is pandas method. See here for head of, I used an open and close curly brace. For tail, head shows the first few rows. If I'm not going to give any values, it will be default, 5 rows will be shown, right? Tail, head. If I specify, because I have so many rows, if whatever number I'm going to specify, then I'll get approx. By default, it is 5, but I can specify whatever number I want. So this I'm trying to analyze it, right? And then whenever I don't have open and close parentheses, these are called pandas attribute, right? Methods will have open and close parentheses. Attributes will not have open and close parentheses. That's the difference. All right. All right. Now, index will tell me how many rows and what steps they are in. All right. And then columns, what are the different columns we have? Axis will say how many axes, X and Y. Sometimes you can also work with multi-dimensional data. You can also work with multi-dimensional data. Right? What is data types? So here all the data types is of type integer. That's what it shows, integer 64, right? What is the gender, what is the age? They are taken directly from hospital data set. So almost it is a benchmark data set. So what is shape? I told rows and columns. Can you know if you guess what is size? How this value arrived? Can anyone of you say? It's multiplication of rows and columns. All right. How many dimension? What is it? And listen carefully. I told you, right? Whenever I take any data set, it is of type data frame, but the values inside the data frame is of NumPy array. That's what you can see. DF and DF dot values will be NumPy. I showed you about NumPys, right? You remember during the session when the theory part was taken. That is called numerical Python. Listen to the session clearly, and last 5 minutes, yeah, we'll be having a multiple choice question quiz. Let's see who is the winner for the day. All right. And also I can take samples, and information will tell me if I'm going to have any missing values. Machine learning algorithm, you cannot work with even one missing values. So to check off with the missing values, I'm going to check df.info. This is a function, pandas function, right? Even sampling, if you want to sample out some data and then work, you can use sample of function. All right. Yes. You are able to understand till this? Are you all there with me? Yes or no? Thank you. And this is a beautiful function in pandas which is called NUnique, which will tell me what is the number of unique values. For high BP, it is 0, 1, low cholesterol, 0, 1, cholesterol check. But BMI, each of them have different, whether they're smoker, yes or no, stroke, yes or no, heart attack or heart disease, yes or no, right? Physical activity, fruits, vegetables, all yes or no, right? If it is for physical, mental health and all, the values are different, right? The and gender and the age, right? And here, if you see, the unique age is 9, 7. Can you see it will between 1 to 13, right? 1 to 13. I will show you this CDC diabetes data set. All right, it has come from this, right? US diabetes surveillance data set. So can you see, this is the data set. Can you see the number is exactly the same? 253,021 rows. And you should try to understand what these means, right? What each of the columns mean, right? So for example, age, no? Can you see age is 13? It is not 1 to 13, it is 13 level category. See, if it is 1, it is 18 to 24. If it is 9, it is 60 to 64. If it is 13, 80 and older. There is something called 13 level age category code book, right? If you don't understand, that's what, if you don't know the facts, then we will not be able to understand it, right? So this is mandatory for us to understand what is the 13 level age category. Just if you Google search it, you will get the codes here, right? And right, according to the code, it works, right? It's like, how do they take 1 to 13, right? 1 to 13, what is the age and what is the age category, 13 level category. Without knowing that, if you try to write your inferences like 1 2 3 4 5 6, then it will not work, right? I can show you here. Can you see, 1 is 18 to 24, age level 2 is 25 to 29, 3 is 30 to 34. Can you see this? So this is a description of those columns. Like patient, male is 1, female is 0. Like no cholesterol, 1, no cholesterol, a check in 5 years, 1 cholesterol, 1 is, yes, they have checked cholesterol, BMI, have smoked 100 cigarettes in their lifetime, right? 0 is no, 1 is yes, whether they have coronary heart disease or heart attack, physical activities for the past 30 days, whether they consume 1 fruit or more fruit per day, or these are the categories. Do they have difficulty in walking or climbing steps, whether they had stroke? 0 is they are not diabetics. 1 is they had physical injuries in the past 10 days. All right, mental poor health care, 1 to 30. General health is 5, you see, right? Like 1 is 5, excellent, and 2 is very good, 3 is good, 4 is poor, and 5 is, sorry, 4 is fair and 5 is poor. Heavy alcohol, like 14 drinks per week and greater than 7 drinks per week for men and women. Able to get it? So this is how you need to understand how the data set works. And then that is what, it's not like age 1 to 13. It follows the code. right? Before taking the data set, that's what I showed you the first picture. We should know the fact. Without knowing fact, if you start working, even you'll be good on machine learning algorithm, then you'll be plotting with 1 to 13 age, but your paper or publication or findings or whatever it is will be futile, right? So value counts will tell me how many people in this data set have diabetes or non-diabetes, right? So, and also BMI. I can put that into Seaborn. Some of you would have worked with Seaborn. This is a count plot. In this data set, I can find more people are non-diabetics, only less people are diabetes, right? And the visualization is better than this, right? With the count. So you can use it, just right click it, save it as image, and then you can use it for your publications, right? So I told you, right, you should not have any null values. So that is what df.isNull.SumOf is used to find whether there is no null values. All right. And also this is another package for visualization, all right, to figure out whether there's no missing values in this data set. All right, if there is going to be a missing value, then you'll have white lines. These are packages for missing number packages for finding out whether there is missing values or not. All right, even in pandas, we don't have much time. I think time is quite challenging for the session. And yeah, we can also group by age and BMI. I've done the group by age and BMI, and also by income, high cholesterol, and high BPs, right? So, and I'm grouping by physical health, all right, and multi-column also I can do education and diabetes, and there's sum of. So, in education, what level and the diabetes levels, right? So this is another plot for again for count plots, and this is box plot to show the range, right? I said general one. See, when the health is good, the BMI is low. When the health is bad, the BMI ranges is more. Able to figure out? So the like this we need to write inferences, right? We need to write inferences, and also with diabetes and without diabetes. Here you can clearly say without diabetes their BMI is less, with diabetes their BMI is more. All right, this is what is so powerful of visualization. Once we do this is box and plot, right? Which works with your kernel density estimate. This works with your kernel density estimates. All right, any doubts till now? Or only I am speaking? Yes, no? All, any doubts till now? I don't know. Am I going fast? I'm going slow. I cannot see none of your cameras. I always keep my camera on for all my sessions, right? All right. Okay, thank you. This is the next thing is the violin plot, right? How do you plot a violin? Right? You see, you have a violin, you have the top, and where the kernel density is more, then the size, the width of the density is more, right? That is what kernel, according to the kernel density estimate. So it looks like a violin, right? And next is the point plot. It is not generating lot of charts. How do you write inference from that? It's very, very important. All right. And this is about bar plot, right? With diabetes and without diabetes. The general health. Onto the x-axis, I've taken general health, and y-axis BMI. So here clearly says when the body mass index is higher, there could be a clear diabetes. All right. And this is called the heat maps, right? Heat maps, it works with correlation, right? You know, different correlations you can do it in pandas. One is Pearson's, Spearman, all right, and by default it is Pierce and Kendall's correlation also you can do. But by default, if I'm not going to give anything and just I'm going to give df.core of, and then it gives me Pearson's correlation. And the correlation between this column and the target. So what is my target here? Diabetes binary. See, whenever it is lower, if it is negative, then these are not good features for me to build my machine learning algorithm. All right. So I think I'll stop with this here. And any questions I can take. And So in machine learning, you need to first define what problem. Here we have taken heart disease. We need to prepare data, find out any missing values or any outliers are present, and then we need to evaluate algorithms, right, and improve the results, and we need to present results. All right, what I'm going to do, I will play a game. All right. I don't know. Ma'am, you have any WhatsApp group for this team? Or if I could give the link, whether they'd be able to get the link. I've given a link to questions. I don't know. Chat is not working for me. If I click refresh, sometimes it goes off. So I've given the link on the question and answers. Can you click the link and join the quiz, please? The link to Shanbag, ma'am. If you have got a WhatsApp group for this FTP, ma'am. No, no, no. The link what I've given to you now, can you share it onto the group? Yeah, I'll see how many of them are joining. Or you can also scan this QR code or give slido.com and then give this number and join the quiz. I can validating the data. Yeah, we need for data validation, we need to figure out whether because we mostly take I personally tell recommend people to take it from benchmark data sets. Only thing in validation you need to check for any outliers are there. Yes, we started with the quiz. Even you first, let's see who has answered. 24 have joined out of 155. Right answer is yes. Deep learning is machine learning because it's on the first place we have Chadravedlu professor, second is Munir, professor, third is Jagdish. Let's move on to the second question. Oops, untitled. Machine learning model, computer vision, deep learning. AlphaGo. AlphaGo is an example of what? The answer is AlphaGo is an example of which model? AlphaGo is an example of which model? I don't know why the second question. All right. The right answer is deep learning. AlphaGo is of deep learning. I'm sorry, the question had not presented properly. Dr. Usha ma'am is on the first place, Jagdish sir on the second place, and Kalpana ma'am on the third place. Let's move on to the third question for the day. Which model identifies to which category an object belongs to? Okay, the right answer is classification was again Dr. Usha ma'am, second Dr. Anish sir, and third is Jagdish sir. Let's move on to the fourth question for the day. All right. And the right answer is super-based learning on the first place. Again, Usha ma'am, Anish sir, and Jagdish sir. Final question that will define who is the winner of the day. Which package is used to interpret images and videos? Out of 150, we have 40 participants. All right. And the right answer is computer vision. And the winner of the day is Dr. Usha Banu ma'am. Congratulations. Next is Dr. Anish sir. And third is Dr. J. Vanita ma'am. And fourth, it is Kalpana ma'am and Premlata ma'am. Congratulations to all the winners. All right. So, what are your learnings of today? I wish post you can just click on the link and you can give what are the three learnings in today's session. All right. So you can click on the link and then you can make a note of my contacts, right? Exactly. I want to complete by 7:30. 8 o'clock. I have another meeting to join back. All right. I hope the session would have been useful. Click on the link and give three of your learnings. All right. And you can visit the YouTube channel, Doreen Robin, and my LinkedIn page is also Doreen Robin on Instagram and on. Yeah. Thank you so much. And this is a company's website, CI.co.in. For faculties, we provide faculty internships and also student internship. All right, anybody is interested to learn or implant training, you can approach us and the different services that we provide. Well, it is beneficial, then you could contact to us. All right, thank you so much to the organizers. Data set? Yeah, 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 a lot of repositories are there, but we need to search it out and find the authenticity of it. Many governments, many country government also they give. We can use it. To begin kickstarting, I generally say use is better. Yes, please. Any other questions? Thank you. Thank you all. Bye. Window.